Lesson 8, Exponential Situations as Functions. The situations we've looked at that are characterized by exponential change can be seen as functions. In each situation, there is a quantity, an independent variable, that determines another quantity, a dependent variable. The dependent variable depends on the independent variable. They are functions because any value of the independent variable corresponds to one and only one of the dependent variables. Functions that describe exponential change are called exponential functions. This is going to be an important thing for the cooldown. 2. For example, suppose T represents time in hours and P is a bacteria population T hours after the bacteria population was measured. For each time T, there's only one value for the corresponding number of bacteria. So we can say that P is a function of T, and we can write this as P equals f of T. The population is equal to a function f of T. We also could have just said, if we're looking for the population, let's just call it P of T, where that would just give us the population. Now, if there were 100,000 bacteria at the time it was initially measured and the population decreases so that 1/5 of it remains after each passing hour, our decay factor is 1/5, so we're multiplying by 1/5 each time. We can use function notation to model the bacteria population like this. Our function as a function of time is equal to my starting value times my decay or growth factor. This decay factor is our multiplier. What are we multiplying by as we go from hour to hour or minute to minute or whatever our independent variable is? Notice the expression in the form of a times b to the t on the right side is the same as in previous equations we wrote. We're just using function notation now. So let's take a look at this. Why can we think of the beaver population as a function of time in years? Go back to what I said was going to be important for the cooldown if you have to. You'll figure it out. Number 2, what is the meaning of the point Q labeled in this context? Well, what does Q tell you about the beaver population? Write an equation using function notation to represent the situation. Well, can you figure out what the multiplier is, the growth factor based off of this? And then can you work backwards to figure out what the starting value is? Because remember, it's going to be a times b to the t. Growth factor, starting value. I hope this helps. Let me know if you have any questions.